simplify each expression. Here we're given 3 different exponential expressions, and each of these uses a particular rule of exponents. When we have a quotient x to the n over x to the m, where the numerator and denominator are both powers of the same variable, we can combine them by taking the difference of the powers. So x to the n over x to the m is x to the n minus n. And we can use this in all 3 of these situations. Let's look at x to the 20th over x to the 10th. Here we have a quotient where the numerator and denominator are both powers of x, so we can combine them by taking the difference of the exponents, 20 minus 10 in the exponent, and 20 minus 10 is 10, so we end up with x to the 10th as our final answer. We can do the next problem similarly, x to the 4th y to the 5th over x squared y cubed, by taking the x's and y's separately. First, we'll look at the x's. X to the 4th over x squared can be combined by taking the difference of the exponents. 4 minus 2 is 2, so that becomes x squared. And with the y's, y to the 5th over y cubed, those can be combined. The new exponent is the difference of the original exponents. 5 minus 3 is 2. So here we have x squared, y squared as our final answer. Lastly, we have one more example, a squared b cubed c to the 4th over abc. We can do the same thing by recognizing that the exponents in the denominator are all 1. Taking the difference of the exponents gives us a to the 1st, because 2 minus 1 is 1, b squared, because 3 minus 1 is 2, and c cubed, because 4 minus 1 is 3. So we end up with a b squared c cubed as our final answer.